Ikuzo.
So I told my boss, well, my thesis project failed, but we should try it in outer space. He said, we'll write a proposal. We'll write a proposal. And so we called up our friends and we sent in the proposal. And I thought, well, that'll never work. But it did work. So a couple of years later, NASA said we would start a study of this mission. And that's turned out into the Cosmic Background Explorer satellite that really did measure the Big Bang. We measured the color of the original material, and it turns out to be colorless. That is to say, it fits a simple formula exactly, what we call a black body function. So it confirms that the cosmic microwave radiation really is the remnant of the very earliest times of the universe. Then a couple of years later, we measured that there are hot and cold spots in the map of the radiation. And that was a very, very important discovery because it now explains why we exist. The early universe was not exactly uniform. There were the hot and cold spots mean density variations as well. So it tells us that there were spots which were just a little more dense than the average place. And the gravity operating on the material in those particular areas was enough to stop the expansion of the material and pull it back to make galaxies and stars and eventually planets. So we're here because of that. So that's pretty important to us. And that's eventually was confirmed by 2 more satellite missions. And that's how come I got to go to Stockholm with George Smoot. And when that was all done, I thought, well, now what am I going to do? There's nothing so exciting I can imagine yet. But I was just sitting around thinking what to do, and I got a call from NASA headquarters. Would you like to work on this new telescope that we're starting to think about? So I said, absolutely, yes, I'll be happy to do that. And we were hoping that it would be a little bit quicker than it is, but that was 27 years ago now. So I've been working on it ever since.
Wow. That's crazy. But let me ask you this right now. You mentioned how you didn't know what to do after the Swedes called. Obviously, I believe that winning a Nobel Prize is something of the greatest honor, especially in your profession. But in possibly anyone winning the Nobel Prize. So, was your mindset at the time? I'm just gonna wait. Like you waited till they called you, or were you like? Did you have something in mind? Let's go even bigger. What was my future for the science and me in it?
Okay, well, stepping back to 1995 when I got that phone call from headquarters, that was before the phone call from Stockholm. So in 1995, I was thinking what new telescope to build. I was working with Chuck Bennett on proposing the Wilkinson microwave anisotropy probe, which did go on to great success and measured the Big Bang even better. But my friends were saying, well, the Spitzer Space Telescope is going to go up soon, and it's not big enough. So I started saying, well, in that case, if it's not big enough, what do we do? How about a telescope that unfolds in outer space? So I was already thinking about that before the phone call came to let's start building something. Now, my idea wasn't going anywhere because it wasn't time yet. But in 1995, we had just repaired the Hubble Space Telescope, and we were starting to get wonderful pictures and data from the Hubble. And the results from the Hubble told us why we needed to build a new telescope. Number one, the most exciting thing at the time was that Hubble was discovering the most distant galaxies we had ever seen. We took a picture called the Hubble Deep Field, and we pointed the telescope in an empty place in the sky for 2 weeks. And the picture was just covered with galaxies. So the result was astronomers were surprised. We thought when we designed the Hubble that we would be able to see the very first galaxies growing. And the answer was, no, you can't. The Hubble is not the right tool. It needs to be bigger, and it needs to be able to see farther back in time and farther out in space, which means you need to have an infrared telescope to pick up the light that was ultraviolet when it was emitted. So, okay, build an infrared telescope that's even bigger than Hubble, and use it for that. So that's how we got started in '95. And by the way, that's also when astronomers were just beginning to realize that there's something called cosmic dark energy, which is making the expanding universe accelerate. And there are planets around most stars. We didn't quite know it yet, but we were just beginning to learn about planets that are there. And so we said, okay, maybe this new telescope should be able to see planets as well. And so we thought about that, but that's a really hard job. So we just said, we'll do the best we can.
So in a weird way, telescopes are tools for space archaeology, as we use them to look into the past. And Hubble Space Telescope, it was revolutionary. It went, if I'm correct, let me read, 13.1 billion years into the past, or in other words, 700 million years after the Big Bang. And James Webb has the ability and even more serious task to go beyond that, to go 100 or 200 million years after the Big Bang. What answers can we get from peaks so far in the past?
Oh, well, we hope to see what were the physical processes that controlled everything. So we see pictures, we see images of little galaxies, and we already are seeing these with the Webb. We're seeing some surprises. Number one, even the Webb telescope is showing us that galaxies grew much more quickly, much brighter, and much hotter than we were expecting based on what we knew before. So we don't yet know what is the reason for this, but we know this is what we're seeing. So in a little while, I'm sure astronomers will have a better opinion about why this is. We might have missed something about the basic physics that governs the formation of galaxies. Because from the COBE and WMAP and Planck missions, we do have measurements of the initial conditions of the universe when it was about 400,000 years old. And then we think we should be able to calculate how the galaxies grow, but we seem not to be getting it right yet. So this is important.
We stay genuine, uncensored and unscripted, and we always will, as we have to order our usual. Share us and subscribe us, and stay tuned until the next Wednesday. Ikuzo!